Hi, I'm Jim Michael McClament,
I'm Ayana Cater.
and today we're here to talk to you about gravity, projectiles, and satellites. Now, centuries before Newton's discovery, Aristotle and others believed that all heavenly bodies move in divine circles, requiring no explanation. Newton, however, recognized that a force of some kind must act on the planets, otherwise their paths would be straight lines. He also recognized that any force on a planet would be directed toward a fixed central point, the sun. This force of gravity was the same force that pulls an apple off a tree. Newton's stroke of intuition that the force between Earth and an apple is the same as the force that acts between moons and planets and everything else in our universe. This was a revolutionary break with the prevailing notion that there were two sets of natural laws. One for earthly events and an altogether different set for motions in the heavens. The union of terrestrial laws and cosmic laws is called the Newtonian synthesis.
Projectile motion is a form of motion in which an object or particle called a projectile is thrown near the Earth's surface and it moves along a curved path under the action of gravity only. The only force of significance that acts on the object is gravity, which acts downward to cause a downward.
Hey, I'm Takia Kennedy, and we will be discussing satellite.
A satellite is a moon, planet, or machine that orbits a planet or star. For example, Earth is a satellite because it orbits the sun. Likewise, the moon is a satellite because it orbits Earth. Usually the word satellite refers to a machine that is launched into space and moves around Earth or another body in space.
Earth and the moon are examples of natural satellites. Thousands of artificial or man-made satellites orbit Earth. Some take pictures of the planet that help meteorologists predict weather and track hurricanes. Some take pictures of other planets, the sun, black holes, dark matter, or faraway galaxies. These pictures help scientists better understand how the solar system and universe.
Still, other satellites are used mainly for communications, such as beaming TV signals and phone calls around the world. A group of more than 20 satellites make up the Global Positioning System, or GPS. If you have a GPS receiver, these satellites can help figure out your exact location.
Why are satellites important? The bird's eye view that satellites have allows them to see large areas of Earth at one time. This ability means satellites can collect more data more quickly than instruments on the ground.
Satellites also can see into space better than telescopes at Earth's surface. That's because satellites fly above the clouds, dust, and molecules in the atmosphere that can block the view from ground level.
Before satellites, TV signals didn't go very far. TV signals only traveled in straight lines, so they would quickly trail off into space instead of following Earth's curve. Sometimes mountains or tall buildings would block them. Phone calls to faraway places were also a problem. Setting up telephone wires over long distances or underwater is difficult and costs a lot.
With satellites, TV signals and phone calls are sent upwards to a satellite, then also instantly the satellite can send them back down to different locations on Earth.
My name is James Blackburn, and what I will be talking to you is about gravity. Now, we all know what gravity is, but what is it actually? Gravity, by definition, is the force pulling together all matter, which is anything that can be physically touched, anything that you can touch and or feel. The more matter that an object may have is the amount of more gravity that will be pulled upon that object. So, things such as planets, moons, and stars will have a greater gravitational pull than things such as a paperclip. Now, what is mass? Mass is the amount of matter within any type of object.
And the next thing we'll be talking about is projectile. Now, when I say projectile, I don't necessarily mean you throw a pencil across the room and it's projected towards whoever you throw it at. But more what I'm talking about is projectile in motion. Projectile motion is defined as any body thrown with some initial velocity, which is then allowed to move under the action of gravity alone, without being propelled by an engine or fuel. Now, the path followed by a projectile is called its trajectory. A projectile moves at a constant speed in the horizontal direction while experiencing a constant acceleration of 9.8 meters per second squared downwards in the vertical direction. To be consistent, we define the up or upwards direction to be the positive direction. Therefore, the acceleration of gravity is negative 9.8 meters per second.
Okay, Takia, so we're going to start answering these questions section of the project now. A park ranger wants to shoot a monkey hanging from a branch tree with a tranquilizing dart. The ranger aims directly at the monkey, not realizing that the dart will follow a parabolic path and thus will fall below the monkey. The monkey, however, sees the dart leave the gun and lets go of the branch to avoid being hit. Will the monkey be hit anyways? Does the velocity of the chart affect your answer? Assuming that it is great enough to travel the horizontal distance to the tree before hitting the ground, defend your answer.
Yes, the monkey will get hit because the ranger shot towards the monkey in a direct path. The dart will drop lower than he intended, and the monkey will fall downward as well because he let go of the branch. They will both meet below the intended path.
As part of their training before going into orbit, astronauts experience weightlessness. When riding in an airplane that is flown along the same parabolic trajectory as a freely falling projectile, a classmate says that the gravitational force on everything inside the plane during this maneuver canceled to zero. Another classmate looks to you for confirmation. What is your response?
It may seem to cancel, but it really doesn't. They are experiencing a state of free fall, so there is no support force, so that's why they are feeling weightless.
Here's a situation to challenge you and friends. A rocket coasts in an elliptical orbit around Earth to attain the greatest amount of kinetic energy. For example, for escape using a given amount of fuel. Should it fire its engines at the apogee, the point at which it is farthest from Earth, or at the perigee, the point at which it is closest to Earth?
The rocket should fire its engine at the perigee because it is the point closest to the Earth, thus having the most kinetic energy.
Okay, Jay, so I have a question for you. Why do the passengers in high-altitude jet planes feel the sensation of weight, while the passengers in the International Space Station don't?
Well, this concept is actually kind of simple. Passengers in an orbiting space vehicle are essentially falling towards the Earth. However, the pull of gravity is balanced by the centrifugal force of the vehicle, which is caused by its rotational speed while in orbit. Thus, they feel weightlessness.
Okay, I can buy that. So, in synchronized diving, divers remain in the air for the same time with no air resistance. They would fall together. But air resistance is appreciable, so how do they remain together and fall?
Okay, this concept is a little more complex. There's quite a bit of physics involved in skydiving, but we'll start with the basics. Once you leave the plane, there's essentially two forces acting on you. The Earth's gravity pulling you straight down, right, and the friction with the air. Now, the friction with the air mostly adds up to push in the opposite direction from the direction you are moving. So basically, it pushes up on you and your equipment. Now, air resistance increases as your speed increases. So when you first start dropping or moving slowly, gravity is stronger than air resistance and you speed up, accelerating towards the ground. However, the faster you drop, the stronger the air resistance is. So eventually, you're moving so fast that the air resistance is equal in the strength to gravity and you don't accelerate anymore. So you've reached terminal velocity for your current body position. Now, falling speed is independent of weight, so providing they have similar built, almost the same air resistance is provided.
Okay. So my last question. When you jump forward, your hang time is the time you feel that you're off the ground. Does hang time depend on your vertical component of velocity when you jump, your horizontal component of velocity, or both? Defend your answer for me.
It actually only depends on the vertical component, and that's for one reason and one reason only, is because only the vertical component deals with gravity.
Okay. Well, thank you so much for your time.
Okay, James, it's time for you to do your part of the question section there. First question. A rock is thrown horizontally from a bridge and hits the water below. The rock travels smooth parabolic path in time t. Part A. First, show what the height of the bridge would be.
Well, since you don't know the actual height of the bridge, you would find that by taking 1/2 of the gravitational times t, which is time, squared.
Okay. What is the height of the bridge if the rock is airborne in 2 seconds?
Well, if the rock is airborne in 2 seconds, then you would plug that in, and you would find that the height of the bridge is at 19.6 meters high.
Okay. And to solve this problem, what information is assumed here that wasn't in Chapter 2?
Well, what is assumed is the variable, that is time, which is to get into the water.
Okay. Next question. A penny on its side, moving at speed v, slides off the horizontal surface of a table of vertical distance form y from the floor. Show that the penny lands a distance squared from the base of the coffee table.
Okay, so the penny would land at the velocity squared times 2 squared 2 times y, the length of the table times gravity.
Okay, so if the speed is 3.5 meters per second and the coffee table is 0.4 meters tall, show that the distance the coin lands from the base of the table is 1 meter.
Well, in order to do that, you would use g equals 9.8 meters per second squared, which is the gravitational average. Then when you square that, the base of the table with the length of the standard gravitational pull, as well as by 2, then multiply that by the velocity, you will get 2.8 meters.
Okay. The planet and its moon's gravitational attract each other. Rank the forces of attraction between each pair from greatest to least.
Well, this is in your book. So, in the book, you would see that according to the gravitational attraction, the letters in which it would align would be B, A, C, and D.
So one of the first websites we're going to go over is URL sophia.org. It's a very helpful website. As you see, you scroll down, you got to the left, you have a bunch of topics. You click here on gravity. It gives you tutorials, questions. You click again. You see that gravity is a force of attraction that exists between all objects and have mass. It explains it. Right here it gives you a video. And if you really want, it gives you a short quiz on the side. You answer it, it tells you got correct, and you can choose another one if you want. We go back. We click on another subject. As you see, it has multiple videos for this one with ratings next to it. And another quiz. Sophia.org is a very helpful website for those still trying to learn the basics of physical science. It's a very good website for studying and for reviewing for tests.
The next website that we have here is SPET, Interactive Simulations. Actually, if you type in the search bar projectile motions, it'll pull up this wonderful game here where you use a brick and you blast it out of the cannon. You learn about projectile motion by firing various objects. Set the angle, initial speed, and mass. Add air resistance. Make a game out of this simulation by trying to hit your target.
Our next website is angrybirdsgames.com, and Angry Birds can relate to projectile by slinging the sling thingy with the bird in it at an angle to hit the cage of the next bird. Here's a demonstration. And this relates to projectile by using projectile motion.
Our next website is cms.gravitationalschools.org. This gives a breakdown on what force and motion is, as well as gravitation, as well as gravity and velocity. I do apologize. And what you can do is go through, and it'll actually give you interactives in which you can go ahead and look through small quizzes, as well as Newton's laws of motion and how it relates to that of gravity. This is more so for those who are visual and or they learn by seeing and memorizing those equations, and it will tell you whatever you need to know. There's about 21 different subjects on this website, and it will give you all the standards and learning objectives for each. There are quizzes on each one, and as well as labs.